Picture this: you're sitting in a room with the smartest people who ever lived. Einstein is there. So is the woman who discovered radioactivity. The guy who created quantum mechanics. All debating whether reality itself is real or just a cosmic dice game. This actually happened. October 1927, Brussels, Belgium. 29 of history's greatest minds gathered for what became the most important scientific meeting ever held. By the time they left, everything we thought we knew about the universe had been turned upside down. And the psychological aftermath? It drove some of them to madness. The fifth Solvay Conference wasn't your typical academic meeting. This was scientific royalty. 17 of the 29 attendees were Nobel Prize winners. That's a 59% Nobel Prize density, a record that will never be broken. Einstein sat next to Niels Bohr. Marie Curie, the only woman in the room, debated with Max Planck. Werner Heisenberg, just 25 years old, held his own against scientific legends 3 times his age. The combined IQ in that Brussels hotel conference room? Conservative estimates put it above 5,000. But here's what makes this gathering truly remarkable. These weren't just brilliant scientists. They were human beings grappling with discoveries that challenged their deepest beliefs about reality, consciousness, and existence itself. The psychological pressure was immense. Some would later describe it as intellectually traumatic. The topic that brought them together? Quantum mechanics. And it was about to tear their worldview apart. For centuries, science operated on a simple principle: the universe follows predictable laws. Drop an apple, it falls down. Heat water, it boils at 100 degrees Celsius. Cause and effect. Logic. Order. Then quantum mechanics arrived like a wrecking ball. Suddenly, particles existed in multiple places simultaneously. Observation changed reality. The very act of measuring something altered its behavior. Werner Heisenberg had just formulated his uncertainty principle, proving that we can never know both the position and momentum of a particle with perfect accuracy. The psychological impact was devastating. These brilliant minds had dedicated their lives to understanding how the universe works. Now they were being told the universe might not work in any comprehensible way at all. Einstein famously declared, "God does not play dice with the universe." But Bohr fired back with equal conviction. The evidence was mounting. At the quantum level, reality operated on probability, not certainty. Picture the greatest detective in the world discovering that clues change when you look at them. That's what these scientists were experiencing. The conference split into 2 camps, creating the most famous scientific feud in history. Team Einstein believed into hidden variables, that quantum uncertainty was just incomplete knowledge. Somewhere beneath the apparent randomness, classical physics still ruled. Reality was real, whether we observed it or not. Team Bohr embraced the Copenhagen interpretation. Reality at the quantum level was fundamentally probabilistic. The universe existed in a superposition of possibilities until consciousness collapsed it into a single outcome. This wasn't just academic disagreement. This was a battle for the very soul of science. One side clung to a deterministic universe where God doesn't play dice. The other embraced a reality governed by chance and observer-dependent existence. The implications were staggering, not just for physics, but for philosophy, theology, and how we understand our place in the cosmos. By the end of the conference, no consensus had been reached. Instead, a permanent rift had opened in the scientific community. What's most fascinating is what happened to these geniuses afterward. Some descended into philosophical despair. Others became obsessed with the implications. Einstein spent the rest of his life trying to prove Bohr wrong. Bohr defended the Copenhagen interpretation with almost religious fervor. The psychological toll was real. These weren't just abstract debates, they were existential crises. The 1927 Solvay Conference didn't just change physics. It changed what it meant to be human in a universe that doesn't behave the way our intuition tells us it should. And a century later, we're still wrestling with those implications.